Hey everyone. So we're gonna take a look at the lab this week. And what I'm gonna do is, the way that I'm gonna be doing the labs is I'm gonna be kind of going through the labs with you guys. I'm gonna post about a lab a week from here on out. Just kind of going through the lab myself, and purpose purpose of that is for you guys to use this as a reference to aid you guys in progressing through your labs, or to refer to it if you have questions. I encourage all of you to, go about taking a crack at the labs on your own at first. And if you run into issues, use this video each week for each lab as kind of a guide. And if you need help past that, feel free to reach out and we can work on something. All right. So what I'm going to do is I'm going to share my screen and yeah, we can get started moving through it. So the lab this week is titled Introduction to Graphing, and you can find this PDF. It should be the second file from the bottom in the week 3 folder. And I'll say something along the lines of Introduction to Graphing, Manual Instructions, or Manual. So this beginning part, I'm going to give you guys the chance to kind of go through it on your own. It provides a little bit of background about what you guys are doing and why you guys are doing it. The nice thing with this is it kind of gives you these time requirements. So ultimately, we would want to be setting up aside about an hour to do so. I don't think this is going to take an hour, but I guess we'll see based on how long this video goes, right? Other things, if there's any steps in these labs that require personal protective equipment or PPE, it'll show. But this lab is completely done on paper and your computer, so that's really all you need for this. So you don't need anything to protect yourself with this. All right, so like I said, I'm not going to go through the background. The background walks you through different types of variables, independent and dependent variables. It also walks you through really the importance of collecting data and presenting data in graphs, and selecting which graph is best for the data you're presenting. As professionals in whatever field we, excuse me, whatever field we decide to go into, we need to be able to communicate with other people within our field and even people outside of our field. And a great way to do that is by representing data in graphs. Small amounts of data could look really nice in a table, or, you can just kind of add it in the text. But for large data sets, graphs are going to be a really important and easy way to communicate our results. So take a couple minutes, pause the video. If you're watching along, read through the background. Importantly, we're going to be needing table 1 for our experiment or for our activity. So go through, read all about this. You read about averages and outliers, confidence intervals, variance. And then once you get down to here, activity 1, go ahead and unpause the video. All right. So I'm assuming if you've unpaused the video, you're ready to go. So what I'm going to do is, I already have step 1 done. I have my sheet printed out. I have my computer handy for activity 2 and 3. And so what I'm going to do is I'm just going to walk through this activity. I'm doing this, I haven't actually read this activity or any of this stuff. So I'm going to be doing it live with you guys, and, kind of simulating what you're going to be going through. So I'm just going to take it an instruction at a time, and we'll move on from there. So activity 1, graphing by hand. A common method to look at data is to create an XY scatter graph. In this first activity, you will create 2 graphs of data from table 1. So I already did step 1. I kind of cheated and went ahead. All right, so step 2, title the first graph, wheat plant height by week. All right, so real easy, just up in the title, write the title. So number 3, we are titling the second graph, rye plant height by week. Y plan height by week. All right. So number 4. At the bottom of the graph, there's a space to label the x-axis. The x-axis runs from the left to the right with smaller numbers starting on the left and the numbers increasing as you move to the right. At the left of the graph, there's space to label the y-axis. The y-axis runs from the bottom of the graph to the top of the graph with smaller numbers starting at the bottom and increasing in size as you move up. We will now label each axis and decide which pieces of data will be our x values and our y values respectively. So yeah, so thinking about this, right, this kind of gets back to our independent and our dependent variables. So our y-axis, or the axis that runs up and down, right, that's going to be our dependent variable. So what is, being measured in our experiment? Our x-axis is going to be our independent variable, or what we are manipulating or recording, right? So in this case, right, let's see what they tell us to do first. So we are labeling the y-axis with height. So we'll go ahead and do that. And that's going to be in centimeters. So an important thing is when you are labeling an axis, you always want to put the units in which you're labeling, right? Like if I put height and I don't label, right, and I'm going to go from 1 to 10, and I don't tell you whether that's centimeters or inches or feet or meters or kilometers or miles, right? Your results could be drastically different and interpreted very differently. And so importantly with a graph, you want to cut down on what someone else looking at that graph needs to kind of guess about, right? It should be very clear and concise, and someone who didn't create that graph should be able to look at it and immediately be able to see or figure out what you're trying to display. So make sure you're labeling that height with centimeters. All right. Yeah, so the x-axis is going to be time in weeks, right? So again, time is our independent variable. So that's what we're essentially manipulating. Now, we're not directly manipulating time, but we're determining how much time we're going to be recording, right? So that's what we have influence over. And then the time has influence over the height of the plants, thus making the height our dependent variable. All right, so we have our x-axis labeled, our y-axis labeled. All right, we're moving on to number 11. So locate the lower left corner of the graph. This will be the origin of your graph. The origin of the graph is where both of the values of the x and the y-axis are 0. Yeah, exactly. So that lower left corner, that's going to be our 0, and that's our common point for our x and y-axis. So the axes need to be numerically labeled. So refer to figure 4, which is right below here, and label the axes. All right. So let's go ahead and do that. So each of the dark lines, so each of the major tread lines, or grid lines, excuse me, that's what we're going to be labeling. So just give me a second to label mine. And that's going to go from 0 to 14. Now, kind of like a hint, right? While you guys are doing this, make sure you're doing this, neatly, because in the assignment sheet that you're going to be doing after this lab, we're going to be taking a picture of each of these graphs, and that's going to be a part of your submission. So make sure you do it neatly. All right. So number 13, starting with the wheat plant 1 data in table 1, count over 1 week for week 1, excuse me, on the x-axis of time, then count up 2 from there to indicate 2 centimeters. Place it out at this point. Repeat this process for the entirety of wheat plant 1. All right, so we're going all the way back to table 1. All right, we're going to use table 1 to fill out our graph. All right, so we have our graph with all of our major grid lines labeled. And so this first graph is the wheat plant. So what we're going to do is we're going to label wheat plant, or we're going to fill in our graph for wheat plant 1, wheat plant 2, and wheat plant 3. And the important thing is when you're doing, 1, 2, and 3, make sure that you're differentiating between them somehow. So either use like a different color pen or a color pencil or something along those lines to make your marks, or do different symbols as I'm going to be doing since I'm using a black pen. All right, so excuse my cough as well. I don't know why I have a cough all of a sudden. I don't have COVID. I have to get tested every week through working at Penn, so I'm good. So, all right, so week 1, we have a height of 2 centimeters. All right, so that's how we would be reading this graph. So you would go over, you would see week 1, and then the height is 2 centimeters. So week 2 is 3 centimeters. All right, and so what you can see is doing that. And so for plant 1, I'm just doing circles. So I have 2 data points thus far. All right, and I'm not going to connect them until the very end. So you're just doing the data points at this stage. Week 3 is 5 centimeters. Okay, so we get a jump there. Week 4 is 6 centimeters. Week 5 is 7 centimeters. Week 6 is 9 centimeters. Week 7 is 10. Then week 8 is 10. Okay. So go back down. All right, and it says to match up with figure 4. So we look pretty good. All right. So, all right. So using the same process, graph the data for wheat plant 2 and wheat plant 3 on the same graph. Yeah, so you will need to be able to distinguish the data. So I got a little bit ahead of myself there. I'm sorry. From each set, from each other. Use a different color or symbol. When you complete, compare your graph to figure 5. All right, so let's go back up to table 1. Let's do the other 2 wheat plants. All right, so, while I'm filling this out, take the time to fill yours out if you're going along with me. And, in a couple minutes, we will compare. So for wheat plant 2, I'm going to do a triangle. And this is a situation where symbols might be a little easier because we have some overlap, right? So putting different colors on each other might not show up particularly well. Okay. Week 6, we have 8. Week 7, 9. Okay. All right. So moving on to wheat plant 3. So wheat plant 3, we're starting at. Oops. Starting at 0. 2. Okay. All right. So let's get back down to where we're supposed to be. All right. Now, so we're comparing to figure 5. So my symbols are a little different, but so they also use triangles and X's, but we have them swapped. Essentially what you want to do is you want to compare your figure to figure 5 and make sure that they look comparable, which mine do. All right. So now moving down to 17. So now we create a legend. The legend is what shows another person what the points of your graph represent, right? So all those different symbols, right? We need to tell, we know what they mean, but now we need to tell someone else what they mean, right? So in step 18, we're creating a legend. So my circle is wheat plant 1. My triangle is wheat plant 2. And my X is wheat plant 3, right? So your legend should look something like that. All right. So now this is a scatter plot. So you can connect them with lines, but you can also leave them just as data points. And so that's what they're going to have you guys do here. So when you submit, you can do it either way, but it might look a little nicer just to leave them as individual data points. All right. So step 19, you're going to redo this with rye plant, right? Rye plant height by week. All right, so let's go back up to table 1. Take a few minutes, and why don't you guys do this along with me? Okay. So remember, we're going to start by labeling our axes. It's going to be the same as the wheat graph, and then we're going to label our grid lines, our major grid lines. So let's go ahead and do that. I know what you guys are probably thinking, right? You know, why the hell am I graphing this by hand when I'm on a computer? Obviously, if you're watching this or you're on a phone and you can even graph on your phone using like Google Sheets, you know, why am I doing this on paper? Well, you're building the skills, right? And importantly, doing it on paper first helps you understand what's going on when you do it in a computer setting. But for the next activity, activity 2, we are going to be doing it on the computer. So we'll see both ways. All right, so rye plant 1. Let's get started. So I'm just going to do this to myself, and I suggest you guys do as well. All right, so now I'm going to do my axis, or my legend, excuse me. All right, we should have something like that. All right. So that is activity 1. So if you're not done yet, pause the video. No rush. Take your time with it. But once you're ready to move on to activity 2, unpause me and we'll get going from there. All right. So if you're back watching the video, I'm assuming you're ready for activity 2. So let's get started with that. All right. So activity 2, computer graphing. Graphing by hand can be useful for observing trends in small data sets. However, as the quantity of the data grows, it can be useful to graph using a computer. This activity will give a general outline of how to graph on a computer. Please note, Microsoft Excel was used to generate the figures for that activity. Your software might look slightly different, and you might need to kind of adapt if you're using something other than Excel, but if you are and you have trouble, just let me know. But it seems like the instructions for this are kind of written with the idea that you're using Excel or Google Sheets. All right, so in this activity, you will graph the data from table 1 into your computer. All right, so open a new workbook. This will open a new sheet, figure 6. Okay, I'm sure we've all used Excel before. So what I'm going to do is I'm going to minimize this. And I'm going to open up my new sheet. All right. So that I can see both at the same time. All right. Open a note workbook. You got that. You will see a large sheet with numbered columns and numbered rows. These letters and numbers can be used to refer to a specific cell. The box where the information can be typed. For example, the upper left cell is A1 representing column A, row 1. Starting in cell A1, type week. In cell B1, type wheat plant 1. Continuing across, putting each title in a new cell. All right, so let's go ahead and do that. So we got week, wheat plant 1, wheat plant 2, 3. And, if you get this issue where they overlap, the cells overlap, you can just extend the margins a little bit. And then we got I plant 1, 2, 3. All right. Move to row 2, type the corresponding numbers into. All right, so we're pretty much what we're going to do is we're going back up to table 1. And we're making this table in our Excel sheet. All right, so that's pretty much what we're going to do here. The other thing I'll note is in table 1, they have like 2.0 or 2.0, 3.0. You don't need to do that in Excel. 2.0 and like 2 or 3.0 and 3 are the same exact number. So don't waste your time trying to figure that out. So we have our data table created. Let's get back down to activity 2. All right, select the data for week through wheat plant 3. You can do this by clicking on cell A1 and then dragging down all the way to cell D9. All the data in the title should be selected for the wheat plant. Yep, so you'll click here and you'll just drag down from A1 to D9, right? And you know it's highlighted because it'll have this gray box. Yeah, so the next several, so they add this little note in here. So yeah, so the next several steps may vary greatly depending on the exact software you're using, but the goal is the same. So if you're using something else besides Microsoft Excel, you know, it might require a little bit of extra legwork on your behalf to like go on to, you know, YouTube and look up some videos about how to pretty much figure out what you're doing. Or what, you know, this is asking you to do if you're using something else. If you're using Sheets, which I think is, or no, Numbers is the Max software. You know, if you have questions with that, let me know. I've used Numbers in the past, so I can help you with that. If you're using something else, you know, and you have specific questions, just let me know. All right. So find the menu labeled Insert. So for me in Microsoft Excel, that's just right up here at the top. So I'm going to do Insert. Then I am going to, among charts, find Scatter or XY Scatter. So our charts are right here. So you could do like recommended charts. But the one we want is, we want XY Scatter. So we just want the one without any lines. So we want, you know, to give you options like scatter with smooth lines, scatter or smooth lines and markers, which will kind of like curve your lines. But we don't want that. We just want a regular scatter. All right, so you just click on that and pretty much everything we just did by hand, it does for us. Which is why no one does this crap by hand any longer. But I digress. All right, so all right, so number 9, number 10, edit the chart title so that it matches the one created in activity 1. This is usually accomplished by clicking. Yep, so pretty much we'll just click on that. And then we want wheat plant height by week. Okay. You can then add a label to your each axis. So yep, so you'll click on this. We'll go see what it says here. You'll typically be looking for a menu option titled Axis Title. Yep. So if you go into quick layout, you can do something like this and you can change your layout completely, or you can go to add chart element and then you want to go down to axes title. So you can do primary horizontal and primary vertical, and it'll add those in. The nice part about Excel is it automatically gives you a legend. So that's cool. Saves you a step there, but you can add a legend manually as well, and I'll show you how to do that. So if you click on this, if you go to here, you can add a legend here and you can change where it is. So like ours is at the bottom right now, but if I do that, it'll place it off to the right, right? So you can change where it is. But we'll go back to the bottom. Keep it consistent. Okay. You'll need to do this twice, once for each axis. Your graph should now look something like figure 9. Yep, so if your graph isn't looking something like figure 9, pause the video, take a step back, and kind of backtrack and figure out what went wrong. All right, so we have our graph. So now we're moving on to activity number 3. All right, so if you had any issues with activity number 2, take a couple minutes, pause the video, go back, figure it out. If you want a couple, some more practice, do the same thing, but with, the rye plants. What you can do is you can select the rye plants. You can go back to insert. You can go over to scatter, go here, and, it'll give you the same thing. And you can fill that out, the same way. Oh, hold on. We don't want that. We want, so this is a little different. What you can do is you can highlight weeks. Then you, hold on. I'm gonna do this because this is just easier to do. So we're gonna shift those. We're gonna reinsert those there. All right. And now you have the same graph, and you can go through and you can do rye plant height by week. And then, you can put your axes in. Height, centimeter. Time, week. All right. And now you see you have both. All right. And that can just give you a little bit more practice. All right. So moving on to activity 3. Now we're going to be talking about some linear regression and actually getting some more data from the the graphs that you're creating, and getting some equations out of it that would not be as easy or time friendly to do in person. All right. So let's go through activity 3. Typically, if you are graphing using an XY scatter plot, you're looking for trends, a recognizable pattern in your data. In this activity, you are looking to see if there's a trend in height of the plants over time. More specifically, you're looking for the rate at which the plants grew. This rate can be determined from the graph produced in activity 2. All right, so in your graph from activity 2, so we're just going to be using this wheat plant height. And then if you want more practice, you can use the rye plant height when you're done with this one. Okay, click on a point from the wheat plant 1 data set. So we'll click on some points. Right click on the data point and select add tread line. Okay. Add tread line. Okay. Select linear. All right, let's see here. So, all right. So select linear, select display equation on chart. Okay. We're going to go back in. Add tread line, and it just does it. All right. So it adds it in. But we want information about that. So instead of doing that, let's go into chart elements. We want linear. Okay. So we did that. We want some more options. Okay, so we have linear. Display equation on chart. So that's down here. What that does is that'll produce an equation that we'll have on our chart. Cool. Hold on, I messed that up. Sorry. So that is, you know what, let's just delete that because that's going to get confusing. Let's delete that. Clicked on the wrong thing to start with. So that's just going to get confusing. If you're following along. So let's eliminate that. All right. Sorry, rewind. We want plant 1 data set. Okay, now we're going to add our tread line. I always like going into more options because it gives us, you know, we can do like logarithmic, you know, we can select linear. Then we go down to display equation on chart. Okay, and we'll drag that to a place we can actually see it. And so what we see is it tells us, you know, the equation should be y equals 1.2381x plus 0.9286. So that's what we have here, okay? And so what we're going to do is write this in the data table. So the data table is right here. So make sure you're recording it somewhere. This is PDF, so it's a little challenging to write this on. All right, so this is the equation of the line. In its general form, it is y equals mx plus b. So, you know, hopefully you guys can harken back to some high school algebra and remember that this is the equation to determine the y-intercept and the slope of the line, right? So the m symbol stands for the slope of the line. Yep. The slope is how far the line rises y over a certain distance x. Yeah, I remember learning this as rise over run. But I'm sure it's some weird fancy thing now since, you know, math can never just be simple. The b in this equation is called the y-intercept. This is the point at which the line crosses the y-axis, right? So it is crossing that way. For the equation from step 6, this would mean that the 1.2381 would be the slope. So that means that it is rising 1.2381 for every one that it moves over, meaning that it is growing, right? Because our rise is in centimeters over weeks. So it's growing 1.2381 centimeters per week on average, since this is a linear line. And this y-intercept would be 0.9286, so that it's crossing that y-intercept, which, remember, our y-axis is here, right? So it's crossing that way at 0.9286 centimeters. So this equation allows you to find the length of the plant at a certain time. For example, if you wanted to know the height of the plant in week 9, based on this equation, which it's basing on averages since we're using a linear line, a linear trend line, the height would be 12.0715 centimeters, right? You can do this simply by plugging your data into the equation and solving for y. So we know our slope, we know our y-intercept, so we know our m and our b and our x, right? We're interested in week 9. So our x-axes, so our x data points are our number of weeks. So 9 would be x. So then we just solve for y, which would tell us our y-axis data point, which is our height in centimeters. All right, so since the slope is calculated from change in y over change in x, it uses the same units as the data set. In this case, this means that the slope has units of centimeters over weeks. The slope then means that on average, the wheat plant grew 1.2381 centimeters per week. Yep. However, right, so this kind of gets into, you know, using what you know to help interpret your graphs, because this linear line presents an issue, right? And so the issue is, right, that it's going to talk about right here, is that all these plants started at 0. All these plants started as seeds, right? So the height is 0. So the y-intercept should not be, our y-intercept is incorrect, based on our trend line. So we need to edit that, right? And so again, when we're dealing with data, it's always important to take a step back and make sure that the data makes sense. In this case, the slope, for an average makes sense, but we know that our y-intercept is wrong. We know that it didn't start about a centimeter high because it started as a seed, right? So now we need to correct that. So we are right-clicking on the tread line and select Format Tread Line. But if you go into more, you can do that here. Sorry, I'm just going to move this over so I can see both at the same time. Okay. Select Set Intercept. So let's find that. Set Intercept. And set the number to 0. Okay. This is setting the y-intercept to 0. You can do this whenever you know the exact value of your dependent variable at the 0 for the x-axis. Write the new tread line in the thing as corrected, right? So because we did that, now it changed our equation, right? So our equation went from this, right, to this, y equals 1.402x. All right, so now that is our corrected tread line. And you guys can write that down here. So using the same procedure, create a corrected tread line for each of the additional wheat plants on the graph, and then write them in the table. All right, so let's do that now. So we're gonna click on here. So I guess I didn't need to delete that. Darn. So I knew what I was doing ahead of time, somehow. All right, so we have our linear, right? So this is for data point 2. We want to set our intercept to 0, and we want to display our equation. Now we're going to do the same thing for the third plant. Okay, we're going to set the intercept to 0 and set the equation. All right, so we have 3 equations, and question 10 is based on the corrected trend lines, which wheat plant grew the fastest. So we're looking for slope, right? Because that's telling us, again, how many inches on average that plant is growing per week. And so for plant 1, we have about 1.4 inches. For plant 2, we have about 1.34 inches. And for plant 3, we have 0.99 inches about. So plant 1 is going to be the wheat plant with the fastest growth. So you can go ahead and fill out the data table. And that concludes lab 1, right? So go ahead and, take a crack at the rye plant height per week graph as well, fill that out, and then make sure that you go ahead and the very last file besides the arts and sciences presentations, if your class has any this week, the last file will be the assignment sheet. And it'll be a couple questions. Take the time to fill that out, add in any pictures that you need to, and then submit that to me when you're done the lab. And that'll conclude your work on lab 1. All right, guys. So I'm gonna stop sharing my screen right now. If you have any questions when you're going through this lab, shoot me an email, let me know. But yeah, have fun with it, play around, get to know Excel. It's a great skill to have and a great program to be comfortable with. And I will see you guys later. All right, have a great one, guys.